Okay, what we have here is a mid-1990s St. Louis Music manufactured crate blue VooDoo 120 guitar amplifier. It's brought in by a good customer of mine, Andrew. Worked on several of his pieces of gear recently, and you know, it's quite old. So I replaced the filter capacitors in the unit. Get my pointer wherever it is here, and I'll show you what those are. These little black cans here that are mounted on the printed circuit board, these are the filtration for the AC power supply, and they have an electrolytic paste inside of them, and they dry up after 20 years or so. Due to the high voltages in guitar amplifiers, it's generally a good practice to replace those, as most people that are involved in this line of work know. Well, I ordered the parts because they're very low profile due to the printed circuit board construction, and replaced them all. And the amp sounded good, and you know, cleaned the potentiometers, which are all mounted on the circuit board. So everything had to come out of this amplifier. You know, all these spade connectors removed from the board. It's a good practice if you're trying to do something like this to mark them with like a Sharpie, or document them with you know, your camera. Well, this had an intermittent noise that was only on the clean channel. It has two channels, clean, which is kind of Fenderish sounding, and dirty, which is kind of a modified Marshall type sound. It's indicated that right now that the clean channel is on. There's the red for the dirty channel. And so looking through the amp with an oscilloscope, I saw that there was a high frequency component riding on the filament supply voltage. And I can show you what I mean now. I have it being monitored right now on my oscilloscope, and that's a nice clean sine wave. And this particular voltage is a low voltage that lights the vacuum tubes. Now when the unit is turned on, taken off the standby mode, what will happen is you get a little bit of loading, a little bit of the flattening of the peaks of the waveforms. But this particular amp had a oscillation on the peaks of the waveforms, on the positive and negative peaks. And what was causing that was, during the course of, I'll go over to the schematic here. Here is the schematic for the unit, the power supply. Since the voltage supplies are derived from the same transformer, and here is the high voltage, it is, and over here is the filament supply and bias supply. What can happen is you can generate some glitches and high frequency components due to inter-electrode capacitances that cause oscillations on the waveform. And this was exactly what was happening in this amplifier. And going back to theory, I said, boy, this has no swamp resistors across the high voltage bridge rectifier, and it also has no snubber caps to bypass those glitches with, you know, to ground, to keep it off, because it's such a high gain amp that any little bit of noise will cause a problem. So I computed out the value of the cap, and I put it across the secondary here, just after the standby switch, and I can show you how it solved the problem on the oscilloscope. If I go over back to the oscilloscope, you'll see now when I take it off of the standby position, the waveform will get flattened on the top, and right at the very top there was an oscillating waveform, and on the bottom peaks. And if that is now gone. So that was an unusual problem, one that you don't often run into, but guys purchasing these amplifiers used could have kind of an aggravation with them. So that's what it was.